Hey, how's it going everybody? In this video, I'm going to go through this Leetcode 125 valid palindrome. Although this question has more dislikes than like, I think this is a pretty good practice. The question was asked by Microsoft, Amazon, Goldman Sachs, Tech Talks in past 2 years. Let's take a look at it together. A phrase is considered a palindrome if first step is convert all the uppercase letter into lowercase letter, and second step is to remove all the non-alphanumeric characters, and also we read the same when we go forward and backward. And also it also explains that the alphanumeric characters only include letters and also numbers. We are given a string, return the true if that's a palindrome, otherwise it's false. There's an example over here: a man, a plan, a canoe, Panama. So first step is to convert all the uppercase letter into lowercase letter. So we will have the big A will be small a, big P will be small p. Second step is to remove all the non-alpha numeric characters. So for example, we will move the empty space over here, the comma over here, also the colon over here, and that's what we will get. And it reads the same when we go from the front to the back and the back to the front. So for example, when we go from A, M, A, N, A, P, L, etc. So it is the same as A, M, A, N, A, P, L over here, and etc. So this is a palindrome. That's why we need to return a true over here. And I'm gonna solve this problem in two approaches. The first one is, I think it's pretty straightforward, and second approach is a improved solution. So this is the first approach. And first we have a list over here. It's empty to begin with. And for all the character in the given string, if that character is a alphanumeric, meaning that is either a alphabet or a numerical number, and we'll append to this list. So by having this if statement, we will skip all the the empty space or the comma or the colon over here. And then before we append to the list, we will convert the character to a lowercase over here. And at the end, when we check if it reads from the front to the back, if that's exactly the same as from the back to the front, right? In Python, when we go backward, we can do comprehension like this, right? If that's exactly the same, and that's gonna be a palindrome. So this is the first approach, and your interviewer might ask you that to improve the solution and without using the extra space, right? What about the linear space? And to do that, we need to use two pointers. Then that's my second solution over here. We have a left pointer and the right pointer. The left pointer starts from 0. The right pointer starts from the back. So we look at the index of the last character. If the left pointer and the right pointer does not cross over, right? So essentially what this for loop is doing is to go from the front to the back, right? So that's the left pointer, go from the front to the back, and the right pointer is go from the back to the front, right here. So for example, we go from here and go from here, and then look at each one of the character. If they are the same, they're okay. If we find that one of the character is not the same, we stop and return false immediately, and that's not a palindrome right there, right? So let's carry on to explain this code, right? So while the left pointer it does not cross over to the right pointer, and also while it's not alphanumeric, also within the boundary, right? So this while loop will keep going whenever we come across a let's say empty space or a comma or a colon, right? It will stop until it's actually a alphanumeric, right? So we will basically again, so we will skip through all the empty spacing and also the comma, also the colon, because it's not important for the comparison when we go through the left pointer, right? So we will keep adding one to it, and the same idea, the way that we will go from the back to the front, we're using the right pointer, and we'll skip through all the alpha, all the non-alpha numeric, right? Also another important condition is that we have to make sure that it's within bound, right? So it's very similar, these two while loops. One is checking the left pointer, another one is checking the right pointer, right? After we get out from here, we can make sure that the string at the L index and also the string at the right index, they must be a alphanumeric, and also they're within bound. And then we converted that to a lowercase and then compare that, right? If that's not the same, and then we stop right there and then just return the false. Otherwise we keep going, right? As I'm showing to you earlier, so keep going. If we can find one of them is not the same, right? So we will stop right there. Otherwise we keep going forward, right? So we will increase the left pointer by 1, also decrease the right pointer by 1 as well. And if this statement is not executed, that means that all the character is the same, right? When we go from the front to the back and the back to the front, and it will return true at the end. So this solution does not take big O n space complexity, but both approaches take big O n time complexity. So yeah, so this is an improved solution. I think it's pretty good practice. I hope you find this video is helpful. Thanks for watching. See you next time.